Okay, welcome to this class, in which we'll begin by recognizing all the devices that we will use in this workshop section. So we're going to start with one of the electromechanical relays that we will be using in this workshop. This electromechanical relay is 11 pin or 11 terminal. This electromechanical relay, as we can see here, between terminal 2, of course, this is a characteristic data that this electromechanical relay has on one side of this device. Between terminal 2 and terminal 10, there's a coil that this electromechanical relay has, and outside of that, it has 3 groups of contacts that we can use to activate different types of devices. Let's start at this side. Here we can see that terminal 1 would become the common between terminal 4 and terminal 3. Terminal 1 is normally closed according to terminal 4, but is normally open according to terminal 3. So when activate the electromechanical relay, when it becomes energized, it will change position. From normally closed between 1 and 4, it will become open, and it will become closed between 1 and 3, and the same will happen on this side. The 6 is the common. It's normally closed with a 5, but it's normally open with a 7. Then when the relay is energized, it will go from this position to this. It will be normally closed with 7 and normally open with 5. And the same will happen with common terminal 11, which is normally closed with 8, but normally open with 9. When our relay is energized, it will be normally open with 8 and normally closed with 9. That's the configuration that this electromechanical relay has, and that we will be using, at least I will be using it exclusively for these workshop classes. And here we can see at the bottom of this electromechanical relay has this shape. There we can see each of the pins that this electromechanical relay has with its respective numbering. So that doesn't mean that we're going to make the connection on pins. What it means is that this part of the relay is attached to a socket or a frame, so that this later is coupled to a DIN rail. And as we can see, it's not placed in any position. There's only one position in which enters, and here it has like a small horseshoe that will make it connect in a suitable way for its base or its frame. That will later be connected to the electromechanical relay. And here we can see the numbering. The numbering below is the one that we're going to use in this case, and there we can make all the relevant connections, but knowing which terminal number corresponds to which place of the electromechanical relay, because there are some that will be the coil, others will be the open contacts, and other closed, other common, and so on. But we're going to make the connection based on this small diagram, which will also be reflected in each of the numbers that the socket of this electromechanical relay will have. So we can do our installation based on that. And this is another relay that we will be using. What's the difference? That the relay we saw previously has 3 groups of contacts. 1, 2, 3. As 3 switches, we could say, and apart the electromechanical coil of the relay. This relay is 11 pins or 11 terminals. But this relay is no longer 11, it's 8. That means that it only has 2 groups of contacts. Here we can see that 3 is the common between 4 and 2, normally closed with 4 and normally open with 6. And 6 on this side would become the common and normally closed with 5, but normally open with 7. And between terminal 1 and terminal 11 is the coil to energize this relay. And here we can see the backside of the relay, which will be attached to this socket, which will later be attached to a DIN rail. Then each of the points or terminals that this has the same numbering, which will help us to determine which corresponds to which. In the same way as in the previous case, they only have one way to connect these electromechanical relays to each socket. Here we can see again this small horseshoe that will make it not to connect in another position. It will always do it in the same way. And in the same way, it has its own socket or frame that in each of the points it has its numbering of which terminal corresponds to each of these, depending on the relay we talked about earlier. Speaking of relays, we will be using these two. One that is 8 pins, 8 terminals, and the other that is 11. But in this case, we'll use, apart from this, time relays or timers. And here we can see the timer brand, the timer code, the standards or the characteristics. This timer works with 50 Hz to 60 Hz. And AC voltage of 220 and a current that supports the contact of this 5 amp timer. And the same happens in this case of electromechanical relays. In this part, we can observe these characteristics that it has, how much current supports each of these contacts, depending on the voltage to be supplied. Practically, this would be the circuit of our timer that we can see here. We can see that the coil where we read source, that will become the coil where our timer is energized, and that will be between the terminal 7 and terminal 2. That will be the coil of our timer. And on the other hand, it has two groups of contacts, and we're going to start with this one. The common would become 1, and this normally closed with 4, but is normally open with 3. When this timer is activated, it will become normally open with 4 and normally closed with 3 according to 1. And the 8 would become the other common terminal that is normally closed with 5, but normally open with 6. Then when the timer is activated, it will go to the opposite case. This timer has 4 options to control the time. It has a range of 5 seconds, a range of 50 seconds, a range of 5 minutes, and a range of 30 minutes. In other words, this same timer that we observe here has those types of range, and we can determine which one to use. If we need to control times of less than 50 seconds, then it's best to leave it here. But if we need to control times of 30 minutes or several minutes, we leave it here. And here's another option, and here's another for more precise times. Another detail, well, this is a connection timer. How do we know if it's a connection timer or a timer to disconnect? Well, here the truth is that we don't find any data that says this is a connection timer. But in the manual that has this timer, this code that we see would correspond to the same code we observe here. So this same brand has several options, but in this case, this code corresponds to this type of timer, which is an on-delay timer. Or, in other words, it's a connection timer. There is also this other one, which is the power off delay, which is the disconnection timer. And in this same timer, there can exist, as we can see here, another characteristic, that is C. Then in these same timers, there are various types that will vary between one class or another. It's going to be the time ranges that it's going to have. So in the case of this timer that we have, which is class C, it's the data that had previously observed here, Now it's another acronym apart from this one, then it will have other time ranges. There we can choose depending on what we're going to control. At the bottom of the timer, there are eight pins that we can see, among which are the timer coil and its auxiliary contacts, normally open and closed. Here we can see the regulator, or the way in which we can regulate the timer based on time, and it will warn us when the timer is energized and when its contacts become interlocked. Here again the timer code, and this is the way in which we can get to regulate the time, or the time scale that we will need. So if we set it up this way, or this way, or this other way, we can do it by moving the levers that we can see in this position over here. By moving the levers that are here, then we can configure the timer so that it comes to be activated at a certain time or another, or in the same time scale it would be. So by uncovering the timer, we can access these contacts to activate them according to what we need. Here we can see another timer. This is a switch off delay timer, or timer to disconnect, and it's better known because this timer becomes more widely used in stair circuits. It's one that I was using for another course I did, but we can also use it in this section. So practically, the function diagram for this timer is that it has a coil between these 2 points. When the timer is activated, it has a contact that will be activated. So this timer, unlike the other, only has 4 contacts. On the one hand, it has the power between A and M, and on the other side, between L and B, it will have its normally open contact. It will only have a normally open contact, not a closed one. But we will see a way to use this timer in these classes as well. Here we can see the buttons that we will use. This is a normally closed push button, or NC. If we test continuity, it is normally closed. And some characteristics that we can take into account is that it can cut this button up to 3 amps, and that it has this shape. We can easily attach it to an electrical cubicle. And here we have our start button, which is green and has the same characteristics as the previous one, only that it would become normally open. So all the devices that we have mentioned here as relay timers are the ones that we will use in the workshop part of this section. It's actually essential to get to know the characteristics of the devices that we need to install. We want to know which we are going to buy, what characteristics they have to avoid unnecessary expenses. For example, in the case of electromechanical relays, we have seen that there are 8 terminal relays and 11 terminal relays. This relay is more expensive. The one with 11 terminal costs more because it has more options, as you can see. It is a little more robust, but the other relay becomes cheaper, or could even cost the half of the other. Hence the importance that we get to know exactly which devices we need to use in our installation. Alright, so for this class, in the next workshop class, we will be testing each of these devices that we discuss in this class. See you at the next workshop class.